Welcome to a new lesson, Sort using Partitioner. Let us take a deeper dive into the partitioning function so that we understand its usage, and that will help us smartly apply it to our problem scenarios. Till now we have seen that the data flows through the map logic, where it is processed and then it goes through the shuffle and sort and partitioning phase, which is all provided by Hadoop, and then it goes through the reduce phase, which again is designed by the user, and ultimately it produces the output result. In this lesson, we would learn how to tweak this Hadoop provided step to suit our solutions. For this, let us break the sort and shuffle and the partitioning step so that we can emphasize on the importance of the partitioner and its importance to the solution. So when you design a MapReduce solution, you should always visualize the data flowing through map, shuffle and sort, partitioner, and reduce function. This represents a logical flow of data. Remember that the actual flow of data is a little different, as map results are sorted and partitioned on the map machines itself, and then shuffled across the network to the reduce machines, where they are sorted again. That flow is the correct and the actual flow. But while designing the solution, you would like to divide your solution in the logical phases as shown. Now, one thing to note is that your solution will have to use sort phase in any case. If you do not want to use the sort phase in your solution, you may think of putting all the logic in the map phase itself and run it without the reducers. Although those kinds of scenarios would be rare, and you would use the sort phase in your solution almost all the time. Now, when you are working on a large data set, there would be many input splits and many maps would be working in parallel. This gives a higher throughput. Parallel processing is the strength of MapReduce framework, and it should be used at all times. But the catch which a newbie to Hadoop falls into is that he or she often forgets to use this parallel processing at the reduce phase, which reduces overall efficiency of the job. Remember that the number of reducers that are being used needs to be explicitly set by the user, while the number of maps are automatically and intelligently calculated by Hadoop, keeping in consideration split size and data locality. So in case of single reducer, what happens is that output of all the maps is shuffled across to the same reducer, and the reducer is working on a commodity hardware. And so all the advantage that has been generated on the map phase is lost during the reduce phase. So it is recommended to increase the number of reducers. Considering the usage of default partitioner, in this case, what happens is that the two reducers output two individually sorted files. But these two sorted files are not easy to merge together into one output sorted file. By easy, I mean that we won't be able to produce one large sorted file by concatenating them. Let us see with an example. Let me just show the input file. I have just added random lines to it. Now when I run with property mapred.reduce.task equal to 2, the program runs. And here you can see that two reducers ran the job. Now I'll ls out6 directory. Here we see two reducer files. Let me just cat part 000 file. And now let me just cat part 1 file. So here you see that the two output files are individually sorted, but when they are concatenated, they won't produce the complete sorted file. So coming back to the presentation, I would put the important points and observations. First of all, the default partitioner is hash partitioner, and we are learning here about the hash partitioner. The logic behind this partitioner is to produce the hash code of the key, and it performs the AND operation with the integer max and does the mod operation with the number of reducers specified. So in this case, what happens is that the distribution of data is so that the result files are individually sorted but need some extra effort if they are needed to combine into a large sorted file. This type of scenario, where the result is in this form, is known as a case of partial sort. Another thing to be kept in mind is that all the key and value pairs that a reducer emits for a key group would be present in the same result file. This is particularly an important point to be kept in mind if you're designing a solution with a chain of MapReduce calls and output of this job acts as an input to another job. In case if you want your solution to output files which can be concatenated to produce one big sorted file, that is termed as a case of total sort. To help design such solutions, Hadoop exclusively provides a partitioner known as total order partitioner. Writing a custom partitioner which can partition the map output into sorted and almost equal distribution of partitions is a little difficult. I would request you to give a think about writing such a custom partitioner which is flexible to sort and partition the map output into equal portions. It would be very difficult, and thus you would be able to understand the beauty of total order partitioner. The biggest challenge while designing such a solution is to divide the map output into a distribution that is almost equal. It won't be efficient if one reducer gets most of the portion of the work and the other one doesn't get any. It can happen so that the key distribution shape is in form of a bell curve. In those cases, dividing the key space by the number of reducers won't give a uniform distribution of workload. Hence, with total order partitioner, Hadoop provides input sampler which samples the input space to find out the distribution and helps total order partitioner to divide the key space into somewhat equal portions. So always you would see implementation of input sampler along with total order partitioner. In the next section, we understand another technique we can apply to our solutions, that is secondary sort technique.